All right, I'm back. So questions. I forgot why we need to save old item numbers in part2 in a priori. What's the answer here? Oh, so when in a priori, when there is an old item number, usually means that you have to remap, right? Remember, if you want to use the triangular matrix, you have to map item IDs to 1, 2, 3, 4, 5, 6, 7, a continuous number series so that you can use that matrix. All right, the question, the online calculator, does it mean only the computer's offline calculator? Yeah, your computer's offline calculator. Chenbai says, I cannot find the recording option that says recording to cloud. My recording went to my local PC. Where do we upload your quiz recording? I'll create a link for you to upload the quiz recording on Piazza. Do we need to start our own Zoom session for recording? Yes, you have to start your own Zoom session. Will the question ask about coding? No, you have done a lot coding in your assignments. All right, let me see if I can find it on the USC Zoom site and show you. If you log into usc.zoom, let me share my screen. If you log into your usc.zoom.us, on the left side, go to setting. There is local recording. There is cloud recording. Local recording, cloud recording. Do not use local recording, use the cloud recording. And choose the options that it will record your shared screen. And that's it. All right, any more questions? You need to unmute. Yes. Can we not practice this Zoom recording thing this time? We can practice that later. Okay, let me just take a count. How many of you want to practice today? And how many of you do not want to practice today? If you want to practice today, just put it in the chat. Okay. All right, good. So the only reason why I want you to practice today is I want to make sure you do it before the exam. So we don't have to practice today. We can do our regular quiz, but make sure you try it before the exam, because when 6 p.m. starts, the exam starts. Okay. All right, so we're going to do our regular quiz today. All right, finding similar documents. Okay, I think that's it for finding similar documents. Next topic. All right, recommendation systems. This is a core topic in this course. So in the recommendation system, there are additional readings. Please read them. And there's one more, the evaluation method. I don't remember which set. That's probably the last set of slides. There's one more required reading. You should read them as well. All right, recommendation systems. We talk about different types of recommendations, right? Important thing about recommendation system in our lecture is we do a content-based recommendation system. In the content-based recommendation system, you need to know how to create item profiles. You need to know how to create, where is it? User profiles. Then with the user profile and the item profile, you need to know how to do the recommendation. And where is it? Oh, you also need to know if we were to use machine learning methods for content-based recommendation system, what would be the pros and cons? And that's it. Also, these summaries are important. I want you to understand the pros and cons of each different types of recommendation systems. And I think somewhere here we talk about TF-IDF, right? Not here. Okay, yeah, TF-IDF. What is TF? What is IDF? Once you generate TF-IDF scores, how do you use them in a content-based recommendation system? That's important. All right, the second part of the lecture, we talk about collaborative filtering. So, okay, collaborative filtering, you need to understand what does it mean by neighborhood-based, and you need to be able to do user-based and item-based collaborative filtering. You need to be able to know the differences between Pearson correlation, cosine similarity, and Jacquard distance. So I think for cosine similarity, we show you here, right? If there is empty field, it might not work, and you want to normalize it, and so on. You don't have to memorize this. You do not have to memorize this. If we are going to test you, Pearson correlation, this will be in the question. Item-based. Oh, there's one important thing about item-based. Okay, you need to be able to compare item-based to user-based collaborative filtering technique. What's the pros and cons of each of them? Read the textbook. This is important. Okay, extensions to memory-based algorithms. These are all very important because many things you need to know, like here, if you have too few votes, what do you do? If you have noise in a CF-based algorithm, what do you do, right? These are good techniques that you can use for your final projects. All right, so second part. Third part. So now we talk about model-based collaborative filtering, briefly talk about clustering, and this clustering will be covered in the clustering lecture. And talk about regression. And all these are very important. What are the things that a collaborative filtering approach is good at? What are the things it can deal with? What are the things that it cannot deal with, right? So you have to be able to explain all this, right? So think about understand how to do item-based and user-based CF, like what you implemented in your algorithm. That's only a part of the knowledge that you should know how to implement an algorithm. But most importantly, I want you to be able to explain why you choose a specific algorithm. What's the pros and cons for a specific algorithm? All right, last part of recommendation system. Oh, hybrid one. This one is also very important because in practice, it's all about hybrid recommendation system. So you should understand the definition of each hybrid recommendation system. You need to be able to explain how it works and what are the problems this type of hybrid recommendation system would be able to solve. And you need to read this paper, how to evaluate a recommendation system. All right, so next topic is clustering. For clustering, we covered the curse of dimensionality. You need to be able to explain this. We also covered hierarchical clustering. You need to be able to explain hierarchical clustering. You need to be able to talk about clusteroid, how to define them. And just like your homework, there are multiple approaches to do the same thing, like finding a distance between a cluster and a point. You need to be able to talk about them. What else? K-means. You need to know how to set K-means, what's the property of K-means, how to pick the initial K centers, how to decide on the K, right? How to decide the K, and BFR. So for BFR, you need to know the assumption of BFR, what are the types of data BFR can process, how do BFR works, how does it summarize all the data, and Mahalanobis distance is important. How does it compare to Euclidean distance? And also Cure algorithm. You need to be able to explain Cure and compare it with BFR. All right, link analysis. So for link analysis, I want you to be able to explain this graph. Where is it? Oh, PageRank. So the intuition of PageRank is important, right? So if you have many links connect to you, you become important. If you're pointed to by an important node, you become important as well. You need to know the assumption of PageRank and this random server idea. How do you use a random server to calculate PageRank? Then once you define the transition metrics, we do have, you need to know what's column stochastic for PageRank because it has an impact for taxation and to deal with dead end and spider trap. You need to know what's the stationary distribution and its property because this is a property that enables PageRank. And this R equal to MR, you need to know how to solve this for R. I think power iteration and also use the principal eigenvector are two methods we covered. You need to know their how does it work, what's the computational complexity of these two methods. Okay, this is important. Stationary distribution. And dealing with spider traps and dead ends. You need to know why these are problems, right? How do they affect your transition metrics? And you need to be able to explain this taxation. And you need to also be able to explain how this map using MapReduce to calculate PageRank iterations using a combiner. This is important. Make sure you read your textbook. Okay, so topic-specific PageRank is important. You need to know how it works. And web spam, this is important, right? So if you change the damping factor, how would it affect your ability to fight for spam farm, right? What are the things in the spam farm? Also, you need to know how to calculate hits, hubs, and authorities, and the definitions of hub scores and authority scores. All right. Graph. So for graph, we started by looking at Gervin-Newman and betweenness. So you need to know how to calculate betweenness scores. And you need to know once you have the betweenness score, how do you use Gervin-Newman algorithm to divide the graph into communities. Then you need to know how to use modularity to cut this dendrogram to find the best setting, right? So modularity, how does it work? How do you calculate this expected number of edges? Then we talk about spectral clustering. So spectral clustering, let's find a target function. Here, you need to be able to explain this target function. You need to be able to say, all right, we have this because of we want to have some, right? What is that something? And you need to know how to solve this grab cut target function, optimize it. And you need to be able to explain this, right? You did it for your quiz and this. All right, spectral clustering and trolling is important. But this one is fairly simple. Once you model your data into this bipartite graph, you can use your frequent item set algorithm. But how to use them, that's important. All right, second part of social networks. This is AGM and BigCram. So for AGM and BigCram, you really need to understand this. What does it mean when you have a model that you will be able to generate a graph? And what does it mean when you have a network that you can find the best model, right? Usually we are looking at finding the best parameters of the model to describe the data. So we came up with a few examples to show you maximum likelihood estimate. You need to understand what exactly is maximum likelihood estimate. You need to understand all the parameters in AGM and exactly how this AGM process works. Although we will not be able to use AGM, but in general, you need to know how do we use AGM to find communities. I think that's one of our quiz questions. Oh, and this is important, right? The overall edge probability, how do you generate this? So with AGM, we did a number of exercise and eventually came up to here. All right, so this is also given a model and a parameter. We want to be able to calculate the probability of this model and parameter to generate a graph. And we say this is not going to work because it's very computational expensive. So we talk about this other algorithm called BigCram. So you need to understand this. I will not ask you to memorize this function, but I will ask you to explain it. Once you have that, how do you initiate this table and start to find the community structure? That's BigCram, right? All right. And also this extension, the directed membership of BigCram. All right, last topic, streaming. In 2 minutes. So streaming, the important part, all these algorithms in streaming are fairly simple. But the important part is I want you to be able to explain, because we are getting approximate answer for many of these algorithms. How do you show the error bound, right? For example, I think the first one is sampling, showing you that you should sample by key, not by position. You should be able to explain why. Then we talk about this reservoir sampling. How does it work? It's important. And Bloom filter. What exactly is a Bloom filter? And how does the Bloom filter, all this M, N, K, and M would change your false positive rate and why? Okay. Right, so something like this. Then we talk about estimating distinct users. Very simple algorithm, but the key is to show that the algorithm would work, right? Here. Oh, not here, sorry. Here. And also you need to know how do you take median and how do you generate the final numbers. Also, moment, you need to be able to explain what moments are and how do you estimate them. And if you want to use second moment, you are using this formula, but why? You need to explain why. Well, you don't really need to explain because it's a multiple choices. I would explain it in the option, and you have to be able to tell if this is the explanation is true. All right, and the last algorithm is about sliding window, and you need to be able to explain the memory consumption of this algorithm and why the algorithm will give you a 50% error maximum. All right, that's it. Any questions? Make sure you read your textbook, read the paper, make sure you understand all the quiz questions. You should be able to do this, okay? All right, so can you post the lecture tonight? Yeah, I can. If the cloud finish processing the video, I will post the lecture tonight. All right, please turn on your video and start your quiz. You can have until 8 p.m. for your quiz, and good luck. Thank you everybody for the semester. I don't think I will see you again on Zoom because you're going to work on your comprehensive exam by yourself. If the summer is open, I am on campus. You're welcome to come to see me. Until then, work on your projects.
Thank you.
All right. Thank you, everybody.
Thank you.
Thank you.
Holding the evaluation so that we can use your comment to revise the course, maybe adding more assignments if you think you need more assignments. All right, enjoy your quiz.
All right, guys, time's up, and I'll end the session.